All right, so you probably have been wondering why the sine squared of theta plus cosine squared of theta equals 1. I mean, who doesn't sit around and wonder that? I know how it is. Here we go. We're going to call this angle right here theta. And why don't we? I could label this a squared plus and b squared and c squared, but let's just call this the O for opposite side, the A for adjacent side, and the H for the hypotenuse from this angle theta here. That's how we'll label this. We could do this however we wanted. But what we're trying to do is show that this is in fact true based off of the right triangle. We also should point out, of course, that a squared plus b squared equals c squared. That's from 600 BC, Pythagorean theorem. But in our case, we would say a squared plus o squared equals h squared. This is, representing the sides with opposite adjacent hypotenuse. So we know that these two things are true. What we're trying to do is show that this is true. And let's do that. The sine, if we break this down to what sine of theta is, it is, of course, opposite over hypotenuse. All right? And instead of labeling these A, B, and C, I already just labeled them opposite. So we're going straight off of SOHCAHTOA here. The cosine of theta equals adjacent over hypotenuse. And we know that's true. So if we, in fact, since they're equal to each other, substituted these two things in for these two things, here's what would happen. So I'll rewrite sine squared theta plus cosine squared theta equals 1. So here's what our goal to prove is. This would be opposite over hypotenuse squared plus, and the cosine would be adjacent over hypotenuse squared equals 1. Now, here's where it becomes a little bit more involved. If you remember an old algebra, so we'll put a little side note star here. Back in your Algebra 2 days, you probably learned that if you have something like a plus b over 2, that in fact equals a over 2 plus b over 2. Okay, that's just how that is, and you can go back and forth from both of these. So that's kind of what I got. I got the same denominator here, and if we go to our next line and simplifying this simplifies to o squared over h squared plus a squared over h squared equals 1, and that comes from the Algebra 2 rule that stuff like 2/3 squared equals 2 squared over 3 squared, which is 4 over 9. And that's how you square a fraction, or take a fraction to the second power. So we have done that here. Now, if we use this rule here, we can see that O for opposite squared plus A for adjacent squared over H squared equals 1. So you see what I did here. I went from here to here and used this rule. Okay, I had 2a over 2 plus b over 2 equals a plus b over 2, so I combined it like this. Now, if I outline this in like purple here, this h, it doesn't stick out too well. Let's do it in like a blue. That looks a lot the same. All right, but this hypotenuse squared, and we go back to here, we can see what hypotenuse squared in fact equals. So if we replace this h with o squared plus a squared, there's the numerator, and on the bottom we call this, we could call it a squared plus o squared, or o squared plus a squared. Do you see that? I can add numbers in any order and get the same answer. That this in fact does equal 1, because anything over itself is 1. Now, backing up, at this h, and this is what's going to separate people who can get this and not, that h is this right there. And that is substituted in here, and you wind up with this equation here. And anything over itself is, of course, cancels and gives you 1, no matter how crazy it looks. So this is why the sine squared of theta plus the cosine squared of theta equals 1. And thanks for listening.